I want to thank the organizers for invitation to this conference. Yes, I've been thinking a lot about Stark units in the last couple of years. I'll be talking about two recent developments that I've been working on in this direction. And they were in particular, very much inspired by Henri Darmon, by Dick Gross, and some questions and discussions I had with them. So this talk will have two parts. The first part is this without the word p-adic. And so this is for a sort of like the Stark conjecture and a mod p analog of this. Mod p and an Archimedean conjecture. So I will call Harris Venkatesh plus Stark. And maybe some of you have heard my bad joke multiple times now, but I like to write it in terms of this sort of Euler characteristic, but I don't want to be subtracting Akshays. And then the second part is a p-adic version of this. Switchboards. Okay, so we're talking about the Stark conjecture, but specifically in the setting coming from weight 1 modular forms, and I'll explain later on why I want to focus on modular forms of weight 1. So in the setting, let F be a modular form of weight 1. Later, I'll take it to be a new form, but let me just say modular form of weight 1 for gamma 1 n. And right by the work of Deligna and Serre, I can associate a Galois representation to F. Note by rho F. The two-dimensional complex representation, absolute Galois group of Q. And in fact, I can take this to be some finite extension. And from this two-dimensional representation, I can cook up a three-dimensional adjoint representation. So this will often, usually this is denoted with a 0, because I'm going to take the trace-free part, but I'm going to omit 0. So this is a three-dimensional complex representation obtained by the action of the Galois group on 2x2 matrices with complex coefficients with trace 0, three-dimensional space, and the action is by taking the matrix I get from rho F G and conjugating some 2x2 matrix. And in particular, this adjoint representation has following nice properties. So one, it factors through PGL2 C at rho F does. Or if you prefer, SO3. And it has finite image. In particular, right, there are only 5 possible kinds of finite subgroups of this. So it's it either has a cyclic image, dihedral image, or has image isomorphic to A4, S4, or A5. So the cyclic case, this corresponds to Eisenstein series. The dihedral case, I'll just call F dihedral. And for these three, call F exotic. And also adro F has an integral structure, which I will use. It has an integral structure given by the following lattice. We call M the Z-span of elements of the form 2 rho F at my Galois element sigma minus the trace of rho F on sigma times the 2 by 2 identity matrix. Okay, so this is my integral thing in the representation. I mean, I'm viewing this as a vector. I'm viewing this as a 2 by 2 trace free matrix. And it has distinguished elements in M at every place W. So these elements look like this, with sigma being the Frobenius at W. So F Frobenius of W minus the trace of rho F the Frobenius of W. If W is Archimedean, I mean complex conjugation. Otherwise, I just need a normal Frobenius element. So for every place, I have some fixed element of my representation vector space. Okay, and in particular, this is a decomposition group invariant element. I'll use this in a second. Okay, so these are the basic objects I'm going to study. So I'm going to outline the following picture of the first half of the talk with these objects. So first we can look at the Artin representation for the adjoint representation. Sorry, the adjoint, what did I say? The Artin L function of the adjoint representation, leading coefficient. In this particular case, the rank with the order of vanishing is 1. And the conjecture of Stark relates this to particular units in OE cross. The Rankin-Selberg method, I can relate this L value to the Peterson norm of F. And so I can take the composition of these things. And this is my Archimedean conjecture.
Sorry, Robert, I'm slightly confused by your handwriting. That's an OE cross. And then up there, when you're defining the integral structure, you've got rho F of what?
Sigma, some element of the Galois group.
That's a sigma.
Yes.
Okay. All right.
Oh, sorry, my sigma is like a
They're indistinguishable from
calligraphy
O's, but now you've told me, yeah, it's okay.
Make it smaller.
Let's move on.
Okay. Let's actually start with some real phenomenon. And then Harris-Venkatesh is a mod P version of this. So I haven't said yet how to define this, but there's some mod P reduction of units in O E cross. And this is related to some mod P value associated to F. We'll also need to define this is Z mod PZ. This will be Harris Venkatesh conjecture, and this is a mod P thing. And I will call this a Harris-Vegetation. For HB. Okay, this is picture for the first half. And go in the following, discuss each of these things in the following order. So top half, bottom. Yeah.
In the triangle you drew, is the bottom edge just because you have the other two edges, or did you mean something?
Oh, I just took the
particular?
composition of these.
Okay, all right.
So I guess it's also important. This is the only thing that's not a conjecture. The other three are conjecture. First, okay, I mean, I'll talk about the star conjecture, but in a slightly rephrased form, which I promise is equivalent to the classical formulation. So I'm going to talk about use some dual unit space instead of OE cross. So let me just define my unit space curly U of ad rho F to be space of Galois covariant homomorphisms from my integral thing in ad rho F to the actual unit. And on this, we have the start regulator map. So this is going to be a map from this dual unit space to R. And it's just defined by taking, so if I fix some Archimedean place, W, right, I get some distinguished element XW, so I can take the evaluation map at XW. Valuation at XW. So this gives me a map for my unit space, my dual unit space to OE cross. And then I compose that with an embedding from W and logarithm to get something in R. So just by picking some place, I get some real valued map on my dual unit space. And so in this setting, the star conjecture for these adjoint representations coming from a weight one form looks like the following. It says that there's some unique element of the dual unit space, tensor Q, such that the leading term of the R10 L function is given by the Stark regulator at that unit. And in a way that's compatible with like Galois conjugation on my representation. So like they vary with W sort of in a compatible way. compatible with Galois conjugation of that rho F. Okay, and I won't say, oh, sorry, that was it's two. I won't say much about the Peterson norm, but it's just useful to know that the Peterson norm is proportional to this L value. So Peterson norm of F is proportional to the first derivative of ad rho, the R2L function, ad rho F as 0, up to some rational constant. So let me let this be the field of coefficients like generated by F. For this is integral of F with its dual dx dy y squared. So I'll use the Peterson norm and the L value change.
For two, it's an exact equality, or is there some coefficient in front?
This, this is an equality. Yeah. Like, I mean, I guess normally in the classical version, you have like this 1 over W, but that's inside this. The U star at XW is equal to this 1 over W sum over Galois conjugate.
You know you're in the rank 1 case of just asking?
Yes.
Can this be trivial?
This is the rank 1 case. So complex conjugation acts on this representation with eigenvalues 1, -1, and -1. So the dimension of things, the invariance of complex conjugation is 1 dimension. Okay, now let's move mod P. So actually, I'm just going to use what I already wrote. Switch. Now let me turn this into a floor. And remove all these R's. Okay, so I want some mod P regulator map. Okay, and when I'm going to cheat notation wise a lot, so I'm going to write Z mod PZ cross, but really I will have to add back the ring of integers of the field that F is defined over, and maybe also have to invert 6n a lot of the time. But I'm not going to write this tensor. So now instead of taking an Archimedean place, let me take a non-Archimedean place. Let me say it's over P. So I still get an evaluation map at XW, which sends me to OE cross. And remember, OE cross is it's like Frobenius invariant, decomposition group invariant. And then if I send this to, it's basically UP cross, I can then take reduction mod W and get something in ZP cross. I guess some part fixed by the Frobenius of W. Get some p-adic thing and then mod p. To get my, so now I have a map that sends units to z mod p z cross. And okay, so that's the unit side. The L function side is a bit more complicated mod p because I don't have an L function. So instead, need to pick up something else called the Shimura class. 5. And actually, well, this is a key part that I'll need in the second half to generalize to something p-adic. But let's take some prime that's not 2, not 3, and does not divide the level n. Let's look at the cover of modular curves. X1p over x naught p. So this is in a tall cover. I mean, it's not really a tall, but you can take a subcover of this. And the Galois group of this cover is z mod p z cross, excluding some 12 roots of unity. But that's why I'm going to invert by 6. This cover gives me some elements of H1 et al. Of x naught p d mod p z cross. Now this H1 et al, there's a map. So I'm going to just do a bunch of homological equivalences. So I can take I mean, I can view this as z mod p minus 1z, and then take the base change of this curve. GA. Z mod pz cross. And then this happens, I mean, there's a map from here to Zariski cohomology. They're the same in this case. Sorry, it's not p. Oh. And then I can use Serre duality to view an element of H1 as the Hom space on H0. Hom of H0 x naught p base change. Omega 1 to z mod p z cross. So the point is that just this cover, the Shimura covering of modular curves, gives me some map that sends cusp forms of weight 2 and level gamma 0p to z mod p z cross. Okay, so I have some mod p valued function on modular forms. But if you remember, the modular form I started with, f, is of weight 1 and for a different group. So we need to cook up a weight 2 form from this weight 1 form. So I have f, which is weight 1 level gamma 1n. So I want something of weight 2 and level gamma naught p. So I can use this Shimura class. So what I can do is I can take f and take its dual form. So if F has Fourier expansion an Qn, then the dual form is just the one with complex conjugate coefficients. I take F and I take its dual form, F star, evaluate that at PZ. Now this is a way 2 form, but for gamma not P and for gamma 1n. So I'm going to take a trace to gamma not P. Gamma 1n intersect, sorry, it's a little crowded. Intersects gamma not P. The trace of f of z, f star pz. So this is the form I can apply the Shimura class to. And so this is how I define the Harris-Venkatesh norm. Sorry, when I say I mean this is how Harris and Venkatesh define this mod p value. So this z mod pz cross number associated to f is the Shimura class on this form, which I will abbreviate. Maybe let me just write this as f star p. This recomposition of p. And now the Harris-Venkatesh conjecture is going to look like the star conjecture.
P star there, you mean the trace of it?
Sorry?
The trace, just the trace.
Oh yeah, the trace of this.
You've written that that's the trace of FFP star, is that right?
Yeah, the trace of the product. That's right. It's the thing that he wrote up there.
Okay.
Okay, so the Harris-Venkatesh conjecture predicts that this value is related to some unit. Some unit multiple of the Stark unit, or and possibly with some additional factor. So there exists some u in this dual unit space, and some positive integer m, such that this Harris-Venkatesh norm is equal to this mod p regulator of that unit, and maybe up to some m, right? But this is not unique. I mean, it's not required to be unique in the Harris-Venkatesh conjecture. So this is something in this rank 1 space. So it's some multiple of the Stark unit. And I mean, so I've intentionally presented these two things, these two conjectures, in a very analogous way. So let me combine them.
So,
Yes.
So the statement as it's written has no content, but the point is that U and M are supposed to be independent.
Oh, sorry. Yes, I'm sorry. This is so that you have a mod p equivalence simultaneously for almost all p. And here, these are global objects associated to them. Sorry, yes. Yeah, if you just look at one, then yeah, they're all in some rank 1 space. But yeah, the point is these 3 global things satisfy mod p congruence for almost all p. Right, so it's like maybe some baby Asa principle mod p reduction. So now let me give my Euler characteristic conjecture. So I want to ask if this is true for the same unit. So there exists some unique unit such that both of these conjectures hold at the same time. Some unique unit such that one, the Peterson norm, is given by the Stark regulator, UF. And two, the Harris-Venkatesh norm is given by this mod P regulator. Or almost all primes.
So you don't have M anymore.
I don't have M, but I have answered with Q now.
Yeah, but still,
There's no M.
it's still.
Okay, so yeah, so
stronger, yeah.
yes, so actually, this is equivalent to Harris-Venkatesh because although there's no longer an M, here it was for all P not dividing 6n. Now I'm just saying for all sufficiently large P. If I multiply both sides by some M, right, it causes it to vanish for small p, and I can absorb M into this no longer unique unit.
Yeah, but what I'm saying is you're kind of specifying M by saying it's the Stark unit in the Archimedean case. So somehow,
I mean, yeah, in some sense, yeah.
I mean, U is specified by the first part, by number one, U is
Yes.
specified.
Yeah. Yeah, no, so that's exactly the
So that's
concept.
nice,
of the
that's.
compatibility. Yeah.
Nice. There's no M once you've specified U that way.
Um,
Also switch the boards on the left-hand side.
Sorry?
Like, could you put the board where
Swap the
you were last writing?
Okay, yeah. And so this construction might seem a little ad hoc and strange. So I mean, the original motivation of the Harris-Venkatesh conjecture did not have to do with the Stark conjecture or Hilbert's tilde problem. So let me just mention that briefly. This construction of this weight 2 thing from this weight 1 thing and the Shimura class was motivated by Venkatesh and Prasanna Venkatesh and Galatius Venkatesh's program on derived Hecke algebras. So in general, they want to construct some degree shifting operators, like homological degree, shifting it from H0 to H1. And that's why we look at weight 1 forms. Weight 1 modular forms are exceptional, right? Because they appear in 2 cohomological degrees. So let X is a modular curve and omega is a Hodge line bundle. There's no simple formula for the dimension of this in weight 1. And H1 is non-trivial. Right, this does not happen for weight at least 2. So we have 2 cohomological degrees where things are happening. And so when you construct the classical Hecke operator, let's start with x1n. Right, usually you add a level P structure, gamma 1n intersect gamma not P. And then you sort of go back up. But here we interrupt that and cup with the Shimura class. Now I get something, oh sorry, this is H0. Then I get something in H1. Same thing. And then I can go back up to H1 of x1n. And I get some derived. And then in this context, what the Harris-Venkatesh conjecture says is that F, which lives here, gets sent to this regulator of some, or the Stark unit, or some multiple of the Stark unit, times the Serre dual of the complex dual form of F. So here we're trying to understand how these derived Hecke operators act. In the broader Venkatesh derived Hecke algebra philosophy, it's the correspondence between these derived Hecke operators and motivic cohomology groups. In this setting, the motivic cohomology group is that they're interested in is isomorphic just to the Stark unit group, this dual unit group. And so we can really explicitly say that, okay, this action is sort of the same as the action of the Stark unit group. That was the non-Hilbert solved problem motivation. Okay, let me say. Okay, so this is one maybe philosophical reason why you'd want to believe this. There are more concrete reasons why you should believe this. So one, I mean, there's experimental evidence for the Harris-Venkatesh conjecture in all kinds, so in dihedral cases and in exotic cases. And also, okay, so I should mention this talk is based on 5 papers. So based on my papers 1 and 2. The Harris-Venkatesh plus Stark conjecture is true for imaginary dihedral modular forms. Yep. Which is just one of the 2 classes of dihedral forms, but actually work in progress is that this also works for real dihedral. So 4 is that this combined conjecture is true for most cuspidal new forms of weight 1 for all these dihedral cases. So we're just left with the exotic ones. And of course, it's important for me to remark that one, I mean, so inside this conjecture is a Stark conjecture. But in the dihedral cases of Harris-Venkatesh plus Stark, this actually reduces to the cases of Stark's conjecture proved by Stark. The dihedral F is true. In the imaginary dihedral case, this is the imaginary quadratic case of the Stark conjecture. And the real one, it actually reduces to the product of an odd Dirichlet character and a totally even one. So we don't have to deal with the real quadratic Stark conjecture. And Harris-Venkatesh without the compatibility of Stark was also worked on by Darmon, Harris, Roche, and Venkatesh. So they proved the original Harris-Venkatesh for dihedral forms, but with some ramification hypotheses, assumptions. And there's also another work by Emmanuel Le Couturier, who uses a slightly different approach to prove a few ramified cases of like a weak form. But the dihedral case is more or less settled. So for this conjecture, what's left, of course, is the exotic forms. But for this conjecture, the combined conjecture, right? Now Harris-Venkatesh and Stark are basically as hard as each other because in both cases you have to construct a unit. Exotic cases, you don't know how to do that. Actually, all of the automorphic content into proving Harris-Venkatesh up to constructing a unit holds for most exotic cases. So what's left is really constructed the unit. So let me move away now from,
Sorry, I didn't. So Darmon and, and Akshay and Harris proved the conjecture on the dihedral cases.
no, with assuming that your form, the modular form F comes from an unramified character. Like rho F is isomorphic to induce representation of
And what extra work is required to combine those two results to prove the combined conjecture is what I'm asking.
So it's two things. So for just Harris-Venkatesh, one is to treat ramified characters. So they have in classical modular forms language a relation to a certain theta lifting that's very difficult to generalize to ramified characters. So I introduced a two-variable modular form, an optimal form. It's constructed from theta series on with using characteristic functions of optimal orders. And it has a very nice property that this two-variable modular form evaluated z at pz is this theta lift that they need. And this is using local theory that extends, so it doesn't matter if your thing is ramified or even exotic. This holds in many cases. And then to use their construction of these elliptic units to get the whole thing. And then there's the plus part. So I have to prove compatibility, which uses like a generalized Siegel-Vey formula.
That's what I was asking about.
Okay, so what's left here is in the mod P setting is essentially just the exotic forms. So what's left is the exotic form Stark conjecture. Let me move now to the second part, which is p-adic thing. Okay, so I'll just start with my wildly ambitious proposal and then explain the components. So I'm going to look at units in this unit space, this civic homology group, if you prefer, and ask that some CP version of Harris-Venkatesh conjecture is given by the p-adic regulator of this unit. Okay, I haven't defined this. And then a stronger version. Although the stronger version, I have no evidence. Maybe let me make it a question. Is replacing U with the Stark unit. So is there something in this philosophy that can give me the p-adic regulators of Stark units? So a more real local global principle. So first, what I'm going to do, right? So there's two components of this Harris-Venkatesh norm. One is the Shimura class, and then one is finding some form to apply the Shimura class to. First, I'll work on ZP cross, and then I'll go to ZP because I'm just going to use the view that ZP cross is Z mod PZ cross times ZP. Right. We have like mu P minus 1 and then 1 plus PZB. So I'm going to work on this thing first. Oh, and this entire content of the second part of the talk is in progress work, which would, so I have 1, 2, 3, 4, and then P. Speculative, but these constructions can go.
What was probably three? You mentioned 1, 2, 4.
Ah, 3 is I just erased the conjecture. It's explicit. Oh, here. It's explicitly saying what is P here. So 3 is how big is big enough? P. And then also I describe this constant explicitly. So I mean, Stark observes this is
What is that?
the ratio of the Peterson norm and the L value.
Oh, I see.
So this is the same as like the ratio between my UF and the Stark unit. Stark observes this is some finite product of Euler factors like Rankin-Selberg L function and Riemann zeta function. I describe it use like the local factors of this explicitly. So I can really relate this unit to the Stark unit. I was about to erase this. Yeah, 3 is the explicit calculation. Like companion for 1, 2.
You refer to when you're saying.
Oh, sorry. So my papers are numbered 1, 2, 3, 4, and P. With primes that are not 2 and 3. It's everything else. Okay, so p-adic Shimura class. Let me start with this. So naively, you want to look at similar covering as I wrote previously over there, but for x1 p to the n over x naught p to the n. Okay, and this has essentially Galois group z mod pz z mod p to the n z cross. But one problem is that this is not at all. And I mean, you can try to think of what's the maximal like at all sub cover, intermediate cover. This is very difficult. So let me instead observe that this is finite flat and produce a class in flat cohomology. PDN. Z cross. Okay. And it turns out that, so this is a Galois group, but let me name this cover PN, like the actual map. These PNs these pi n's are compatible in the following sense. I can take the limit of these things. So take an inverse limit, the direct limit of H1 flat of x naught e to the n z mod p to the m z. Okay, I'm just for convenience give this the completed cohomology of x naught p infinity cp cross. So I get some class in here, and I can do the same maps I had before and Serre duality to view this as something in Hom of completed cohomology, zeroth cohomology, Zariski of x naught p infinity omega 1 is dp cross. Oh, sorry, I skipped this step. So I can do this, but actually what I wanted to do was, no, I can't do this. So what I wanted to do is, this is my z mod p to the n z Shimura class. So I have multiple Shimura classes floating around, and I'm being a little bit sloppy. So now I get some ZP cross Shimura class. And I'm going to break this up using the isomorphism of ZP cross as the Shimura class on Z mod PZ and the Shimura class on ZP. From the isomorphism I wrote down. So this is what I meant. First, I work on ZP cross. And then I take out this ZP one. And then from this,
And if you just work over X1,
so I get,
yeah, if you work over X1 of P. I'm a little confused because your N and your N are varying.
yeah, so now I'm letting the M
Same.
and N vary.
Yeah, so
One
usually
goes
when you do
forward, one goes
homology, you have this, but your N and M are the same in your class.
Yeah, but I can still take, okay, I'm also skipping some details, but you know,
This,
I'm gonna take a direct limit on the first N and a projective limit on the second N.
yeah, so I don't see how you. Analyze it. Yeah, I think I see what you have to do.
So
Yeah,
like-
what you wrote is not the full construction. You
Yeah.
have to do some.
Um, so, okay, now I'm gonna take out this ZP one, which is in this flat completed cohomology, and then H one,
Did you move the board, Robin?
sorry.
Online people.
For the online
Oh,
people.
I did move. I moved it before the question.
Oh, I see, okay.
Uh, Um, and then I do the same sort of things and then use Serre duality to get of H0 completed Zariski of X naught P infinity omega 1 ZP. So now I have a ZP valued Shimura class. But the source, right, is this completed cohomology space. So now what I want to do is to go for my F, which is again weight 1, level gamma 1 n, and get something in this completed cohomology space. Have my Shimura class. Now what I need to do is I'm going to construct like a projective system of spaces of modular forms. From F in the this way, so compatible system of modular forms, cusp forms. I'm gonna do something similar to before, where I apply some form to some power of P on the argument. And then I look at the space of modular forms generated by these things. So I define V sub F comma P to the N to be sum of levels from 0 to N of VP F P to the I. So I take like a sum of these things. This is a subspace of cusp forms generated by these guys. It's in H, no, at X, sorry. X gamma 1 and intersect gamma naught P to be N plus the divisor. And in fact, this forms a projective system. So they're trace maps from like F from the P n plus 1 to the P to the N. And I can take an inverse limit of these spaces. And in fact, this space is non-zero. It can be zero if P is 2 or 3. I mean, in general, I don't really want to consider 2 and 3, but if you want to consider 2 and 3, it's non-zero as long as P is ordinary. And if P is bigger than 3, then this is always non-zero. And it has I can explicitly tell you what the generator of this is. So it's at most one-dimensional, generated by f hat, which looks like at each finite level, alpha 1 minus n, f p to the n minus 1, minus alpha to the minus n, the central character of f of p to the n minus 1. Alpha is the root of this Hecke polynomial, the unique roots.
What does it mean P is ordinary?
Here I mean ord of AP with 0.
Of what? What is AP? AP of?
This is the P coefficient of f.
But F is a form that doesn't have P in the level, right? F starting gamma 1 of n.
Yes, I mean, okay, so this only matters if P is 2 or 3.
Oh, okay, that's what. Okay.
Squared minus APX plus omega P. Okay, so I gotta tell you what the explicit generator is. And okay, so I can write down the solution to what I wanted here. So I'm going to take f and send it to, so I'm going to apply this procedure to f dual.
I'm still confused. I mean, what is the weight of this F?
F is weight 1.
And why is the constant term of the Hecke polynomial having P in it? Yes. Your F is weight 1.
Yeah.
Not your F times F of P. Okay, maybe we'll talk about it later. Confused.
So whatever the Hecke polynomial is, apply this procedure to f dual. So I get some projective system and it has a unique generator. Now this is something in H naught, the completed cohomology, and I combine that with f to get some weight 2 thing. And then this is something I can apply the Shimura class to. And then in the p-adic conjecture, that's what this norm is. Shimura class ZP of this thing. Maybe I have to trace, but yeah. This thing. So this is in ZP. Again, like in the first half, okay, maybe I have to tensor with C adjoint F, like but yeah. Okay, so I've defined the things in this conjecture. I have no time, so let me just make some remarks now. So I don't have a proof of this conjecture, but so for one, there's also a derived Hecke algebra interpretation of this, just like in the mod P case. I can take this Shimura class and define a derived, like a degree shifting operator from H0 to H1 on the completed thing. So sort of in the Venkatesh philosophy, you expect some kind of relationship like this. Let me switch the camera. Yeah. Okay, so let me just quickly. Okay, so my dream was to have some a global Stark picture for the actual Stark unit. There are a few interesting developments that make me hope that this could be true. Okay, so first there's one question that independent of that, I mean, in order for some local global picture to arise, I actually need U to be at least somehow explicitly related to the Stark unit. I've given a weak version, like in original Harris-Venkatesh, there's some multiple Stark. There is interesting in progress work, as I understand, by Emmanuel Le Couturier and Loic Morel, where they, in the Z-P, in the mod P case, they have a formula for the Harris-Venkatesh norm given in a different way. This is in terms of modular symbols. So if this could be computable, and if this could be upgraded, for example, to some ZP thing, maybe there's some hope of getting some conjectural, like what should this p-adic regulator of the unit look like? And yeah, I mean, it would still be interesting to at least, I mean, I think there's a chance for this to be explicit, even just, if you just look at, say, p squared over x1 p squared over x0 p squared. I mean, expect this to have some interesting connection to p-adic L functions. I don't know what. I mean, happy to give this talk here because there are a lot of experts here who know way more than I do. But for example, there's this speculation by Oscar Rivero, who speculates that there's some conjectures there's some triple product p-adic L function with some Baylis and Flock elements that relates to some hypothetical p-adic Harris-Venkatesh conjecture. I wonder, maybe there's some connection to his speculation, or to other p-adic L functions. And should also mention, so this is all done concurrently. So Gyujin Oh, who has been thinking about similar problem of formulating like a more general version of this in sort of the Venkatesh philosophy, using like p-adic geometry in the work of Pan Lue. Right, I mean, these two things, think techniques can flow either way to answer some of these questions. And I mean, if we forget about Stark units, if we forget about units, there's also, you can consider similar questions for other covers of Shimura varieties. Right, this construction of the Shimura class, okay, maybe there's no unit, but other people have considered other similar kinds of coverings in these Shimura classes that come out. I'll just mention them. So Stanislav Atanasov's thesis 2022, he looks at high dimensional Shimura varieties. Alex Horawa and Prasanna Horawa. I forget if that's this year or last year. 3. And Gyujin Oh's thesis. These two looked at some kind of analogous settings, I mean, in the broader Venkatesh framework with motivic homology for like Hilbert modular forms and Siegel modular varieties, Hilbert modular varieties. In this case, okay, we don't get Stark units, so, but there's a lot of interesting other phenomena that can happen with other Shimura varieties. Oh, and sorry, I'm over time, but I also want to, just a few days ago, last week, Francesca Castella and Castella, Wang, Erickson, they posted a preprint where they give, I mean, not exactly in the setting, but they give like a backwards, they give a degree shifting map from H1 to H0 using some p-adic methods. So I wonder if there's some, yeah, what's the interplay of this and the supposed derived Heck algebras? What happens there? But anyways, yeah, thank you.